Today's unit we are starting is the algebra unit on polynomials, and our first topic with this unit is algebraic definitions. So you do get this all in your modules. All of these definitions will all be there. So we're going to go through the definitions today and look at the examples of it as well. All right, so most of the terminology that we will be using in this algebra/polynomial unit. The first definition is the constant. So this is a number that always will have the same value and there will be no variable attached to it. So for example, these are just numbers, right? But if you see an expression like x plus 9, the 9 would be the constant. Here's another expression. We have 2x plus 6. So this 6 is the constant. Variables, you guys already know what a variable is. These are the letters. It's a letter or letters that may be replaced by numbers. They can be substituted by numbers. So any letter. All right, so here we have some letters. In this expression, we have x plus z. So those would both be variables. Here we have 3x, which is the same thing as 3 times x, and that x would be the variable. All right, so when I say expressions, these are formed by combining constants, variables, or both, by adding, subtracting, multiplying, or dividing. So anything like this, any of these would be an expression. So ax plus 3b, 5y, 2a minus 7, and so on. And notice none of them have an equal sign, right? So an expression will not have the equal sign. Okay, so next we get into terms. So a term is each part of an expression and it's always separated by a plus or minus sign. So that's very important, knowing how many terms are in an expression. So, for example, here we have an expression in this example. We have ax squared plus 5xy minus 7x plus 3. So a term is separated by a plus or minus sign. So this would be one term, two terms, this is the third term, and this is the fourth term. So this expression has 4 terms. The variables in this expression are x. There's an x here, an x here. There's a y. There's also another x. The 3 here would be a constant that we looked at on the previous slide. All right, let's look at our second example here. We have a 2x, so that would be one term. Then we have minus 9. So this expression has 2 terms. Therefore, we'll get into the naming pretty soon. But 2 terms here, and we have the negative 9 here. That would be the constant. All right, next, factors. Factors are numbers or variables that form a product, right? So for example, 2 times 3 gives us 6. So 2 is a factor, 3 is a factor, 6 would be the product. So those are the factors, and that is the product. So similarly here, if we look at this expression, we have the expression AB, so the factors would be A and B. Here we have an expression 3x squared y, so therefore the factors here are 3, x, and y. All right, the next slide here, we're looking at coefficients. Coefficients, so co kind of meaning beside, so coefficients are either going to be numerical or literal. Now, literal coefficients are the variables. We don't talk about literal coefficients very much, but numerical coefficients you do need to know. These are the numbers that are associated with a product. So for example, if we had 32a, the numerical coefficient would be 32. If we have the expression negative 34x squared, then negative 34 is the numerical coefficient. Here we have 3.4, m cubed, z squared, so 3.4 is the numerical coefficient. All right, so if I just give another one here, if I had 2xy plus 7x, the 2 here would be a numerical coefficient, and the 7 here would be the numerical coefficient. All right, and then compared to literal coefficients, these are the variables, are the letters that are associated with a product. So same examples as the top, but the letters now are the coefficients. So here the a is the coefficient, the x squared is the coefficient, the m cubed, z squared are the coefficients. All right, but literal meaning the letters, and then numerical coefficients meaning the numbers. All right, so next we are looking at polynomials. So a polynomial is going to be a monomial or the algebraic sum or difference of monomials. So they've used the word monomial in there. We don't even know what that is. So let's talk about a monomial first. So a monomial is going to consist of any or all of these following subcategories. So a monomial can be any integer, right? Just like these, positive or negative. It can be any variable with a positive integral power. So for example, y, a squared, m to the power of 5, negative a, negative e. And it can also be the product of integers and variables. So 2x, 3a squared, negative 3x squared y cubed, and so on. Notice there's no addition or subtraction in between terms. All right, so it's just one term. That makes up a monomial. A binomial, so mono meaning one, bi meaning two. So a binomial is the sum or difference of exactly two monomials as shown below. The other way to look at it is there's two terms, right? So a plus b squared, there's two terms, therefore this is a binomial. 3x squared is one term minus 5 squared, that's its second term. So 3x squared minus 5 squared, that's another binomial. Here we have 7x minus 2y, so again there's two terms, so therefore it's a binomial. Last expression, 3x plus 7, again two terms here, separated by the addition sign, so therefore a binomial. Tri meaning three, so now it's going to be the sum or difference of exactly three monomials as shown below. So our first example, our first expression, we have ax squared plus bx plus c. Those are three terms. 1, 2, 3. Three terms. Same thing here. We have a minus b plus c. Three terms. Therefore trinomial. 4m plus 7n minus 18. Again, three terms. And same thing with the last one. 2x minus 3y plus 7x. Three terms, therefore a trinomial. All right, after that, if we get into polynomials that have 4, 5, 6 or more terms, then they are just called polynomials. All right, so you do need to be able to differentiate between a monomial, binomial, or trinomial, and then when it is a polynomial. Poly meaning many. So next we are looking at degree of polynomials. This is the largest exponent in a polynomial or the greatest sum of the exponents in any single term of a polynomial. That will give us the degree of the polynomial. So for example here, these are 0 degree polynomials, okay? There's no exponent. There's no variable with an exponent. Here we have first degree polynomials. So for example, 3x, that's x to the power of 1. So therefore it's the first degree. Negative 6m, first degree as well. 2y, first degree. 3x, first degree. This one already has the exponent of 1. So those are all first degree. Second degree polynomials, they have the exponent of 2. So 5x squared 5y squared. Here, it's 9a to the power of 1, b to the power of 1, but together, when we add those together, it gives us an exponent or a degree of 2, because we can add the two exponents together in one term. So here we have 13xy, again, 3x to the power of 1, y to the power of 1. This is one term, so you can add those exponents together. 1 plus 1, so it's still a degree of 2. Here we have a trinomial, 4x squared plus 9x minus 3. We're going to look for the term that gives us the highest degree. So this term has an x squared. This term has x to the power of 1. All right, this term in the expression, so this is the whole expression here. This term has a degree of 2. Therefore, this polynomial, this trinomial, is a second degree polynomial. Next, let's look at examples of third degree polynomials. So the first one, 6x cubed. Here, this term is negative 5x squared y. So remember the y does have an exponent of 1, right? So therefore, 2 plus 1. So this term does have a degree of 3. Here, this term is 2abc. Each one of those variables has an exponent of 1. So again, you can add 5xyz. Again, each of those variables have an exponent of 1. So you would add to give us 3. Here we have a trinomial, this expression here, 5x cubed plus 3x squared plus 8. So this term is a second degree term, and then this term is a third degree term. So again, we're going to look at the highest degree in the polynomial. So this would be a third degree polynomial. All right, here we have a binomial. It's 3ab squared plus 9ab. So if you look at this term here, 9a to the power of 1, b to the power of 1. So this would have a degree of 2. Here, a to the power of 1, b to the power of 2. You can add those together to give us a degree of 3. Okay, so this just continues, but let's go to fourth degree. But just remember, it could go more than fourth degree. It could be fifth degree or sixth degree, and so on. All right, so this first term is just 3x to the power of 4, so that's pretty easy to figure out. It's a fourth degree. This one here, a squared, b squared, so you can add those together. That's a fourth degree. Here we have a trinomial, and again, you're going to look at the term that has the largest exponent, so this here is fourth degree. And then here we have a term, 9abcd. So again, each of them have an exponent of 1, so you would add those together to make it a fourth degree polynomial. All right, so last two definitions here. The first one here it's called the standard form of polynomials. It's called the descending order. All right, so descending order of polynomials. This is the standard way of writing polynomials, is writing the polynomial from its highest to its lowest degree. All right, so if we look at this first example, it's negative 3x cubed plus 8x to the power of 4 minus 3x minus 2x squared minus 7. So we do have to rewrite this in descending order. This is the standard form. So you're going to take your terms from the highest exponent. So our highest exponent was 8x to the power of 4. Next, we have negative 3x cubed, so that would go next. Next, we have negative 2x squared. Notice you have to take the sign in front of the term, right? So this is a negative 2x squared. So we've taken the 3x cubed, 8x4, negative 2x squared. Next, we have the negative 3x placed next. And lastly, we have the constant, which is negative 7. All right. And There are 1, 2, 3, 4, 5 terms in this expression, so therefore it is a polynomial. All right, let's look at our next example. So this is the expression here. 3x plus 2x to the power of 4 minus 7x to the power of 5 plus 9. So you're going to take your largest exponent first, which is the negative 7x to the power of 5. I'm going to write that first. Plus 2x to the power of 4. Then we have the 3x, and then plus 9. All right, this is 4 terms. Again, it's a polynomial. All right, here, the exponents, they're all degree 1, all of the terms. So in something like this, then we would just write it in alphabetical order. So we would take 3a first. It's positive 3a, positive 7b, positive 5c, and then the negative 8x. All right, and then the other way to write it is the ascending order of polynomials, but this is not the way that is used very often. It's just to show that it can be written in ascending, which is smallest to largest, or lowest to highest degree. Okay, so the constant is written first, the negative 2, then we have the positive 3x squared, then the 5x cubed, and then the negative 7x to the power of 5. All right, so again, remember to take the sign in front of the term, if it's a positive or negative. Okay, and then here, 7x is written first. It's a degree of 1. Then we have the 3a squared, degree of 2. And then the 9x cubed, and then the negative 8x to the power of 5. All right, but this is the standard way of writing. This is how we will be writing. It is in the descending order. All right, so the first one here, how many terms are in each of the following expressions? So terms are separated by addition or subtraction. So 1, 2, 3. So this has 3 terms. This is all together. It's 5x, 2y. It's just being multiplied together. So this would be 1 term. So here, again, addition and subtraction will separate terms. So 1, 2, 3, 4. So this has 4 terms. And here, this is division. If we wrote this out as like this, it's 1 term. Okay, so just recall that terms are separated by addition and subtraction. Addition or subtraction. All right, so here we just have to label it if it's a monomial, binomial, or trinomial. And again, this is based on how many terms are in the expression. All right, let's go over these ones. So the first one here, okay, well, we have to label each polynomial if it's a monomial, binomial, or trinomial, and that's based on terms. So the first one here, this has 2 terms, so therefore it's a binomial. Okay, this one, 7x, 2y, that is 1 term, so this is a monomial. Okay, here we have 3 terms, 1, 2, 3, so therefore it is a trinomial. And this is just the 1, so this is a monomial. All right, next we have to state the degree of each of the polynomials. So we are stating the degree. So the very first one, a to the power of 8. This is a term, and its exponent is 8. So this is an 8th degree monomial. Here we have a trinomial. This term has a squared. This term is to the power of 1. So this would be a 2nd degree. Let me just write that down. 8th degree. This would be 2nd degree. All right, here we have our term here has an exponent of 3. This has an exponent of 2. So again, we use the highest the highest exponent, so this would be a third degree. All right, 5x, first degree, because it's x just to the power of 1. So first degree. And the last one, this has a degree of 5. This has a degree of 2 plus 2, which is 4. This has a degree of 3. So the highest value here for a degree is 5. So this would be the 5th degree. Good. All right, so this next slide we're looking at finding the constant in each expression. So here the constant is positive 9. In this expression, the constant is positive 5. And in this expression, the constant is the negative 5. All right, last slide. We're just going to circle the numerical coefficients. All right, so we are going to circle the numerical coefficients here. So this 3 is a numerical coefficient, and the 4 here is a numerical coefficient. In this one, we have 2.6 is a numerical coefficient. The negative 3.6 is another numerical coefficient. 7 here is a constant. For x, we can say 1, right? Because there is a 1 in front of the x. So there is a 1 there. That could be its numerical coefficient. And then here, we could say the 7 is a numerical coefficient. There's a 1 here, a positive 1. That would be a numerical coefficient. And then here, there'd be a negative 1, which would be the numerical coefficient.